This lesson is about rotation. When we rotate an object or a point about another point, the distance remains the same. So that's very important to remember that when you are rotating a point about another point, the distance between them stays the same. The point that we rotate about it is called the center of rotation. And we can have our rotation in a clockwise direction or in anti-clockwise direction. Let's look at two examples to explain it further. Here they are telling you in example 1, rotate point B about point A by 90 degrees in anti-clockwise direction. So we are rotating B about A. So A is the center of rotation and B is going to move around it in a way that the distance stays the same. So this is A, this is B. And we want to move anti-clockwise. So we connect A to B, then we go anti-clockwise by 90 degrees until we get to B dash. So B dash is the position of B after being rotated by 90 degrees. So that is the point B, and that is the point B dash. As you can see, when we have a rotation, the center of rotation becomes the center of a circle, and the path over which the point B moves is part of the circle. And the radius of this circle is whatever is the distance between the center of rotation and the point B, which is going to turn. And then we go by 90 degrees, that's 90 degrees. And when we get to 90 degrees, we stop and we got the point B dash. So in other words, the angle made between the two lines which connect the center of rotation to the original position and to the rotated position is 90 degrees. And anti-clockwise is this way and clockwise is this way. So we went anti-clockwise this way. That's anti-clockwise. All right, that was for a point. What if we want to rotate a shape? If you're rotating a shape, you need to rotate all of the points of the shape. But if your shape has vertices or corners, you can rotate the corners, and if your shape is made up of straight lines, then you can connect them with a straight line. So, for example, if your shape is a square, you can get the corners of the square and rotate the four corners, then connect them with straight lines. In this example, example 2, they are asking us to rotate triangle ABC, that is triangle ABC. And we want to rotate it about the point O, that is the point O. By how much? By 180 degrees clockwise. All right, so that's the point O, that is the original shape, and we want to rotate it by 180 degrees clockwise. One thing also, when you're talking about 180 degrees, it doesn't matter if it's clockwise or anti-clockwise, you get the same answer. It is only for 180 degrees. Anyhow, so let's start with point A. So connect the point A to the center of rotation, which is O. So we got this OA. Now this needs to move in clockwise direction by 180 degrees. So rotate this OA by 180 degrees and you get this position. Now the end of your line will be here. So your line initially was OA, now it is OA dash after 180 degrees of turning. Alright, so we got the image of point A after rotating by 180 degrees. We do the same with C. So connect O, your center of rotation, to C and rotate it by 180 degrees. So go by 180 degrees. I haven't shown it here because it becomes too crowded. So rotate it by 180 degrees, and when you're doing that, when you're rotating by 180 degrees, you end up at point C dash. So that's C after 180 degrees of turning around O becomes moves to that point, and we call it now C dash. Alright, similarly for B. Connect the center of rotation to B and keep rotating it by 180 degrees. I've shown that with this green line. So connect O to B and rotate it by 180 degrees, and then the point B will fall on B dash, and you will get here. Now we got all the 3 points. After rotation, we can connect them together with the straight lines, and that will be the image of this triangle. So triangle A dash, B dash, C dash is the image of triangle A, B, C. That is how we found the image after rotation. Thank you very much for your attention.